some motivation of the EU-HOU and some kind of chronological report. So you see the vision of the EU-HOU, astronomy, science education to inspire pupils, of course, and to awaken their interest for science. Because this is famous result of a poll in different countries where you ask young people if they want to become a scientist. And it's very famous, you know already that. But the result is that in rich countries, almost nobody wants to become a scientist, especially girls in red. Wow. And in poor countries, everybody, many people, young people want to become a scientist, but they have not the tools to become that. So it's very impressive, and GHOU, Global HOU, has something to deal with that. So the motivation is that for a long time we have been teaching the same way, but research has been done on the effective of the instruction, and the results show that lecture alone is not the most effective way to teach students basic concepts. See a common accurate model teaching. So teaching by telling is surprisingly ineffective. If you want the students to master concepts, they must be active. So this is interactive teaching. I am not a specialist of didactic and so on, but some interesting facts like that, which is called the preconception about how the world works. When the students enter a lecture hall, if their initial understanding is not engaged, then they fail to grasp the basic concept. Or even they may learn, but for a contest, but after they outside the classroom, they forget everything. And for instance, when the children touch something on the stove, they learn that temperature increases as distance decreases. So close means more. It's called the phenomenological property. And it translates, for instance, in astronomy, close means more. It's hotter in the summer because we are closer to the sun. Okay, you know that. And even some teachers still teach that. In primary school in France, I have seen teachers saying that. It's the same for the sound and so on. The brighter means hotter, all brighter must be very hot, and so on. So, some people, like especially in the US, you have the references there. They have made a big study for comparing traditional lecture-based courses to courses incorporating interactive learning strategies. They made a multivariate modeling of data around for several thousand of pupils. And there with many variables, big study. And the result is not surprisingly, for instance, students which have 4 years of college, more math and science background, of course, they gain better. But most importantly, the level of interactivity is the single most important variable in explaining the variation in gain, even after controlling all other variables. So what is important in teaching is that the pupils are active. They are doing something by themselves. Some, just to be, some quotation. A mind is a fire to be kindled, not a vessel to be filled. It's written very long time. Also, it's not what the teacher does that matters, rather it is what the students do. And also the fatal pedagogical error is to give answers to students who do not yet have questions. There are a lot of things, but I have no time to discuss conceptual changes. Okay, so, hands-on universe in Europe. The motivation was, this is not in order, the motivation was to stimulate the excitement for science, of course. A very important thing also, it was to try to reverse the can-do attitude. It's amazing that, especially girls, or high school girls, mathematics, science is not for me, it's too complicated. To reverse this can-do attitude. Of course, if you want to have a literate citizen, science is part of the culture. For instance, in France, some high-level politician people are almost proud to be ignorant in mathematics or in science. Promote the scientific method by inquiry-based method, acquisition of key skills, critical thinking. For teachers, very important, it's a continuous professional training. Communicate the intrinsic value and worth of research. This is more for me. I am not a teacher, I'm just an astronomer, and it's important for me to communicate the intrinsic value of science and research. And of course, participate to the modernization of Europe for the first time. How you can do that? Learning by doing science. By using interactive astronomy. This is the possibility to observe with robotic telescopes, to acquire process astronomical data, so to work on real data and for the pupils to measure by themselves something on real data, and the possibility also to use the virtual observatory, which is right now too much complicated to be used for education, but it will become possible. Also use frontline of the astronomy, of course. So all the resources are developed in close collaboration between researchers and teachers. Use of real astronomical data from solving experience to put the pupils in a situation as close as possible as real research, modern research. And the resources ready to be used by teachers, flexible enough to go further, and so on. And more importantly, the core project is to create a network to share educational tools, experience, and so on. So it began in 2004 with 8 countries in Europe. It was partly funded by the European Union. And then some more countries joined, and now the last project was 14 countries in Europe. You see the leaders in each country there, and some of them are here. This is the entities, the universities mostly, or science center like Sweden and so on. Okay. And the overall objective of this project was the pedagogical use of the worldwide telescope network in optical and radio telescope, because for instance, the Swedish partner built a radio antenna, which is available for education through the internet. So optical and radio. The production of resources like exercise based on real astronomical data, available in English and in all the different European languages involved in the project. The development of the SALSAGI, as you know, network of researchers and teachers, specific website, free access, multilingual portal to all available resources, and last but not least, dissemination through workshop and teacher training sessions, because this is the most important thing. You must help the teacher to use these new tools and to follow them after. Observing tools, radio telescope, optical telescope, Fox telescope, south and north, even in the Tarot telescope also, webcams, many things. SALSAGI software, you know that. Platform, even sometimes it doesn't work on Mac, but this is Java modularity, multilingual, and so on, free of charge. Some example of what we can do, a multilingual interface. The learning science by doing science. This is some examples of what has been produced as exercise. You have seen yesterday from Doppler effect to extrasolar planets, the distance black hole at the center of the Milky Way, and so on and so on. Just an example of the satellites. So the pupils have this image. They can, with salsagy, they can do the photometry of different stars, and when it is sufficient, they can apply the period luminosity relation and they derive the distance to the satellite. Here, it has been shown already yesterday. You see the transiting exoplanet. So when the planet is passing, if by chance we are more or less in the plane, or the orbital plane of the planet, there is a transit, and with these images, you can, with the salsagy photometry, you derive, it has been explained yesterday, but just to remind you that this is a very good exercise, and it is working very well in classrooms. Another means to detect extrasolar planets by the radial velocity method. So, as it has been said already, most of the planets and the star are orbiting the center of mass. You do spectroscopy. There is a redshift when the star is receding. The planet is invisible. What you are trying to detect is the small motion, periodic motion of the star around the center of mass by spectroscopy. When the spectrum is done, but when the star is receding from you, there is a redshift. When it is approaching you, there is a blue shift. This is measurable. Now you know that now a lot of astronomers, professional astronomers, are all their lives to do spectroscopy like that to detect extrasolar planets. So it has been, you see the spectrum. So we provide to the pupils 11 spectrum like that, which is the sodium line. So as a function of time, and by measuring the wavelength and comparing with the laboratory wavelengths, you can derive the velocity curve. And from this curve, you can derive the mass of the planet.
Roger,
yeah.
That must be a world record for a PowerPoint slide. You had 4 animations live. How long when we download it, will all the animations go with it? That's fabulous. Okay.
Suzanne explained that, the element spectra, and you derive this curve, and you can do a lot of things with that. The mathematics teacher can do a lot. Okay. Some examples of what has been done in classroom by students using either the Stokes telescope for another transit, or for the black hole, transient black hole in the binary star, and or small telescopes, all kinds of variable stars and so on. The mass of the black hole at the center of Milky Way, it has been explained, but it's so important, amazing, that I can come back. Thanks to the adaptive optics system, you can resolve the star at the center of the Milky Way, and with a lot of pictures, you can recover the complete rotation of the star around the center. And you derive the mass of the black hole at the center. Okay. How to enter a galaxy, so it has been explained yesterday. So, this is the welcome page of the EU-HOU website. So, this is the address. There's a lot of things. And this website is, you see some numbers, about 4,000 visits per month, and on 4,000, about 1,000 teachers regularly visiting the website. It means something like we can, something like 120,000 European pupils exposed to it. And the most important things, again, the teacher training. You have some pictures of training session which has been organized. Altogether, we have organized at least, I think, 6 or 7, something like that, European teacher training sessions. And more than 100 teachers have been trained. Just to make some publicity, remember that in 2009, there was, during the Czech presidency of Europe, there was a conference, and this project, EU-HOU, has been awarded the silver medal of the European Union. Silver medal, but it was not in silver, it was in plastic. Also, as it has been said by Rosa yesterday, now the GTTP and HOU are included. You said it's not sure, but I think it is included in the decadal strategic plan.
We are in the strategic plan, but we are not a program group.
But maybe it will change next year for the General Assembly.
Everything will change.
Everything will change. They will, the education at the International Astronomical Union will be completely reorganized next year. Okay, so at the end of last year, in October 2010, the EU-HOU teacher training and support program was ended, and this is what we have done during the 2 years project. New exercise in English, new release of SALSA-G, worldwide telescope networks, they use that enlargement resource, updating the website, dissemination through teacher training sessions. Some example of the teachers at different locations in Europe.
Looks like a fortress.
You were in Cardiff. Did you get any visits by the international baccalaureate people?
By the international?
Baccalaureate people. Did they know about this?
They know about.
They know about.
No, they know about EU-HOU, but.
Right now, there is a new program which is called the EU-HOU Connecting Classroom to the Milky Way. It began a few months ago for 2 years, and funded by Europe, and it is focused on radio astronomy for the development of the first European network of radio telescope for education. So it is opening a new window to classrooms, the radio window. And by the way, the training of teachers is absolutely crucial in that way, because at least in France, when you speak about radio astronomy even to teachers, they don't know at all what it is. And then, of course, the development of the resources with this, what you can do with these observations. So now some countries quit, but a new one joined, Germany, and so 11 European countries are involved in this Milky Way project, radio astronomy project. And within this project, and maybe at the end of this year, there will be 5 radio telescopes in Poland, in Romania, in Spain, in Portugal, and in France. Small antenna radio telescopes dedicated to education and usable through the internet. And there is a 6th one which is in Sweden, but already available, already in operation since several years. This was a kick-off meeting in Paris some months ago during winter, and the university is involved in that. So this is a small radio antenna of 2.3 meters. The spatial resolution is only 7 degrees, so it's not good, but 7 degrees is enough to, for instance, to map the hydrogen in the H1 21 centimeter, to map the hydrogen in the Milky Way. It's not enough to map in other galaxies, but in the Milky Way it's good. And the spectral resolution is very good. So, small radio antenna prototype already exists. There is one in Sweden since several years, but a new one, so in Paris already exists now. You see some what is being done in the Paris campus. It's not so easy because you have to provide, for instance, an internet access for the 5 telescopes. For the software, it's not an easy task. And you have to calibrate the antenna and make a lot of measurement, calibration, data entry. But it will work, and 3 developments has been done. There is a simulator, so you can simulate on internet, you can simulate the observation. There is a web interface for piloting the small radio antenna and the analysis and the teacher training. There was last April in Portugal a session focused on radio astronomy.
Question okay? So on Ancala now has web interface, or will have a web interface? Because I know Kathy Orme always, he had to do Unix.
Yes. It's not yet working.
But it will.
Yes, I hope.
Great.
So this is the address of the simulator. You can go there, and you will be able to observe, to map the Milky Way in the H1 centimeter, 21 centimeter radio search. And you can, you have the map of the Milky Way in radio, in optics, or infrared. You can click on somewhere in the Milky Way. You have immediately the radio spectrum, the velocity, and you reconstruct the velocity curve of the Milky Way. And you can go until the concept of dark matter. So this is in operation. Now it's available and it's working. We have done also an exhibition on radio astronomy because it's a completely new domain for schools, in particular for middle schools. So this is the exhibition, some example, but now it is in French, but it is available if you want to translate in every language or in English. It's no problem. EU-HOU is also involved in a new project called Discover the Cosmos, which is an FP7 project coordinated by Greece, and which is the goal is to use the scientific center infrastructure for engaging science education, classroom education.
What's FP7?
FP7 is Framework Program number 7 of European Union. So FP7 means all the research in Europe is in the FP7 framework. But all the research and some part of education also. So in FP7 it's billions of euros. For instance, in that program, we will use a lot the CERN databases, the research facilities of CERN, and all the astronomical experiments like Gaia. And the idea behind Gaia, you know what is Gaia? It is next year there will the European Space Agency will launch the Gaia satellite, which will observe billions of stars in the Milky Way in a very precise way, astrometry and even spectroscopy. Gaia will discover millions of variable objects, and the idea, and you need to increase the scientific output of Gaia, you need a follow-up observation of these variables, and the idea is to give a variable object to a classroom, a teacher or somebody, to follow up the object and to increase the scientific output of Gaia. This is the idea, but it's not so easy to implement.
How many more? It's about time for questions, so a few more minutes.
Few more minutes. No, it's more a report of what has done.
Okay, so
No, it's not longer.
5 more minutes then?
Yes, okay.
Okay, good.
So activity is more focused now in France. Every October there is a festival, science festival everywhere in France, but in particular in Paris and another town in Le Mans, and we are present there. Every year there is also a festival right in the center of Paris, a festival open to the public and free, of course, on mathematical culture and games, and so we are present. Every year we are presenting HOU to all the students, PhD, all the graduate students in astronomy and astrophysics in the Paris region. And I have some initiative also in French-speaking African countries like Tunisia and Algeria. For instance, in Algeria, they have created the first PhD courses in astronomy and astrophysics. So I try to help them. Activities toward teachers is very important. So we are collaborating with some entities in the French Ministry of Research, which is called Sciences à l'École, for training, equipment, and the curriculum. As it has been said yesterday, now the extrasolar planet is included in the official curriculum in France. For high school, I don't remember the level. every year, of course, there is the annual national meeting of French physics teachers where HOU are presented by Suzanne and Michel Fay. In the southern part of France, in Aix-Marseille, the academy, there is the implementation of teacher training focused on remote observation or on photometry or spectroscopy, which is done at the Observatoire de Haute-Provence, including observation. New exercises are now in the process to be available. For instance, equinoxes precession. So the pupils can, with the Stellarium software, they can derive the cone described by the rotation axis of the Earth during 26,000 years. Gravitational microlensing, this will be another exercise to what is the gravitational lensing and microlensing. And they will measure directly on images to recover the gravitational curve, microlensing curve. The speed of light is very important. It has been studied yesterday by Isoti about creation.
Right.
The speed of light. If they believe that the speed of light is finite, it's impossible that the age of the universe is 6,000 years. So this exercise will show to the pupils that the speed of light is finite through the Romer experiment, the Stellarium, but also they can also observe with the IO satellite.
Will it be in English?
Right now it is in French, but it will be in English, no problem. And European error, the last thing, which is the most important, it's again the teacher training session, formation, training of teachers. And within the European Comenius action, we are proposing now 7 EU-HOU training sessions and 2 seminars on radio astronomy. And you have the dates, and it's available to all European people, of course, teachers. And but you have to register very quickly now. So this will be this training is 5 days training on HOU tools, and there already has been 3 trainings at the beginning of this year, and this is only 2 days focused on radio astronomy with now the small radio. This is an example of the 5 days training within the Comenius.
1 second.
Just an example.
I just wanted to look at that.
Oh, Suzanne and Michel are.
It's very heavy.
Yeah.
Teachers end up like, but they learn a lot.
But they learn a lot, and we are very happy to follow these 5 days. They are very happy, and they meet other teachers from other countries, and after they collaborate. Sometimes teachers between different countries gather and create their own Comenius project.
One has been just awarded.
One has been just awarded. There is France, Portugal, Romania, Bulgaria, and Poland.
Again.
What I want to ask for teachers is that if you have a look at the schedule, a really short example that I gave to you, let us say in 10 minutes, we spend 3 hours for teachers to do everything step by step and ask many questions. I think this is very important in teacher training, to have time, because when we have 5 slides here, we have 3 hours there. And I suppose teachers say that it is very important for them to be sure to have good foundations, as I said yesterday.
Although,
This is the strength of Comenius, to give us the opportunity to have time long enough for real work. Because Roger said at the beginning that if you want to teach to students, you have to be sure that they have a question. If you teach before any question, it's no sense. And when training teachers the same, if you teach to teachers before giving them time enough to ask questions, it's nonsense of course. So I really insist, because we all not do anything, just give them the ideas, and that's completely wrong because we have too much space on the internet. So it's not the idea that we need. The ideas we have plenty, the questions we have plenty. But what we have not is taking a question and taking time to work all along the question. 3 hours is the minimum. And then, after that, the teachers can go back and use really with their students, being confident enough to use and teach to other teachers. Thank you.
Yeah, basic teachers need to done by themselves the exercise. Yes.
I can't hear the question.
Sorry.
I'm sorry. Just for myself and teachers I know and saying, when is it studying English close to saying where I can alert people to a number of things to go attend?
It's from EU-HOU website.
Yeah. Okay.
Just go there, Comenius Wednesday.
It's going to be
Yes.
okay.
Why it was the end, just to recall a famous quotation by Carl. You are right.
It's from Suzanne.
Anyway. Okay, thank you.
Are there any more questions? Yes, I would like to add something. So I want to say that Roger has been a very kind man because when we prepare all the exercises, we have plenty of questions, and he has been patient enough for us to go and see in his office very often. Because even when we thought the exercise was ready, we wanted to go on. For example, with Radial, my husband has made the exercises about visual speed of light and so on. But we are not, the exercises exist, but we have not spoken about today because we want to test it with our students. And then we shall have new questions. And then we shall go again and annoy Roger. So I think it is very important for us to have met someone like Roger, and it's very rare for people who are listening to one another. So thank you, Roger.
While Susan gets set up, Vivian, would you like to say something?
Yeah. I just want to tell you that that was the most impressive PowerPoint I've ever seen in my life about all, like, summarizing our philosophy and, and research and summarizing all the conferences and what's going on and the best exercises that we all want to do. It was amazing. So I just want to make sure that it gets linked on the site. So that's one. And then the second thing is, are you the guru of J now? Because, we want to help make it better. So people like Rebecca and others of our interns with Mark's help, can help do some programming and things. So, yeah, I just want to tell you that this is me.
Hey, Carl.
Actually, since Roger and Suzanne and Michelle were not here for my opening talk, I wanted to emphasize in the opening talk, I made it very clear how FHOU and EU-HOU were the organizational spirit and guidance for GHOU. And I think we all, in fact, so RM and us also Jay, we owe in the activity for black holes, and we all owe so much to FHOU and EU-HOU. I just think you've been such great collaborators. I hope we can be
alone. We are not alone. In the EU-HOU, for instance, there is also Radial.
Anyway, thank you.
And the others.
Thank you.
Thank you. Please stand by.